Okay, so here is the lesson for trig ratios that I told you guys that I will do for you guys since I had not been present on Friday, and for any of you that just need to hear it all over again. So first we are going to cover the definition of trig ratio, which we say is the ratio of two sides of a right triangle. And since we're using the word ratio, which is part of our definition, a synonym to recall of ratio is just the word fraction. Okay, so we're just looking at a fraction, a value that represents two sides of a right triangle. There are a couple of things I want you to remember about a right triangle, and that's a right triangle is a triangle that must have a 90-degree angle. When it comes to a right triangle, we always talk about how it has two legs and it has one hypotenuse, and that's going to play an important role in this lesson. Okay, so we're going to talk about three important ratios: sine, cosine, and tangent. There are actually 6, but for geometry we are just looking at these first 3. Okay, so if we're going to stand at a certain angle, and it's always going to be an acute angle, by the way, so I'm going to make a note here that angle is always going to be an acute angle. And if you cannot remember what acute means, acute merely means the angle that is less than 90 degrees, okay? So whichever acute angle you're standing at, if I asked you to find the sine of that angle, you are going to look for the opposite side, the length of that side, and set it over the length of the hypotenuse side. Okay. If I'm asking you to find the cosine, you would take the adjacent side to your cosine angle, not to your cosine angle, to your acute angle, and set it over the value of the length of the hypotenuse. And last but not least, the tangent, you would take the length of the opposite side, put that in the numerator, and then the length of the adjacent side, you would place it in the denominator. There are some popular mnemonics out there that help you remember the definitions of sine, cosine, and tangent. And the one I've used over the years, because it's just funny, and sometimes laughter helps us remember things better. So here it's basically like an acronym that helps us remember. So the capital letter of every single one of the words I'm going to write represents the beginning letter of the trig function and the beginning letters of the ratio values. So here we go. Some old hippie caught another hippie tripping on acid. So just a little funny thing. So notice it's just an S-O-H. So there's your S, the O, and the H. C-A-H, C-A-H, and then the T-O-A, T-O-A. So just many different mnemonics out there. Like I said, this one's kind of funny. A lot of students remember the word Sakatoa, but the problem I have with that one, sometimes when they do Sakatoa, they kind of forget, is it C-A-H or C-O-H, and it confuses them. But you find, whether it be a mnemonic or you just merely memorizing it, please memorize these ratio values. So that's that part first, okay? So again, there's the S-O-H, the C-A-H, and you choose your preference, okay? All right, so first we're going to work out this table, and this is just helping us learn how to read and find our values at a certain angle that's stipulated. So let's go ahead and put here what our definitions are. For sine, we know it's going to be opposite over hypotenuse. Cosine is caught another hippie, T for tripping on acid, or Sakatoa. And we are asked to stand at angle A. Now there are three pictures over here on the left. I'm going to shift over here. And angle A is right here. So this is where they're wanting us to stand, at angle A. Okay? So if I'm standing at angle A, the first thing I want to do is label my sides based on me standing right here. Okay? Now one thing I want you to know is that when it comes to the words opposite and adjacent, these are always going to be leg values. Always, always your legs. And I'm going to come up here in the corner where we have some space. I'm going to draw a right triangle here. And I want you to recognize that our legs are always going to be the sides that form the 90-degree triangle. Okay? The 90-degree angle, my apologies. These are your legs. So this and this side and this side will be either your adjacent or your opposite length, okay? It just depends where you're standing. These are your acute angles, okay? So when you come over here to this picture, let's go back to this one, okay? I know this and this form my 90-degree angle, so either this or this are going to be my opposite and adjacent. The slanted side, the side that's across from 90 degrees and is the longest side, that side is your hypotenuse. So I always tell students, listen, go ahead and label your hypotenuse first, because that's always the easiest one. I'm going to go ahead and zoom in here just a little bit, just to have a better focus, okay? So always find your hypotenuse first, okay, from where you're standing. So I'm standing here, that's what I'm circling here. Now, if I'm standing here, this is either going to be my opposite or my adjacent. You remember I told you these have to be the legs. So since it is across from my angle, this is going to be the opposite side. So I'm going to put OPP for this side. The side length that touches my angle, the one that touches the angle, that will be my adjacent side. Okay? So based on what this is, if they're asking me to find the sine of angle A or the sine of 36.87, which was this right here, all I need is the value for O. The value for O was 3, and the value for H was 5. Okay? So let's do the same thing for angle D. Okay? So angle D, they're wanting us to stand right here. Okay? So angle D, I wish we had chosen angle E instead. That would have been better. But angle D, again, I'm going to put O for opposite, A for adjacent, H for hypotenuse. If we did angle D, we're going to have 0.63 over 1.05. And I'm going to use my calculator just to help convert it to a fraction. So I'm just going to come over here and clear out what I have. I'm going to put 0.63 divided by 1.05, and I'm going to hit the math fraction button. See this math button right here? That one right there? I'm going to tap that. And the first option is going to ask, do you want to convert it to a fraction? So I'm going to put enter, and I'm going to hit enter again. And there's my 3/5. Okay? So I'm going to put 3 over 5. We're going to do the same thing over here for the next one. As a matter of fact, you know what? I'll let you do that one on your own. I'm going to let you do that. Well, let me just go ahead and do it. So for angle G, let's look at this picture again. We're over here at angle G. This is still going to be the opposite side. This is my hypotenuse side and still my adjacent side based on where I'm standing. Again, I'm standing at where I circle that, okay? So if I need the sine of the G, I'm going to put 117 over 195. And that too, if I put it into my calculator, same thing, 117 over 195, and hit the math and hit enter twice, I will get the 3/5 answer again. So 3/5. Okay, so what's the purpose of us looking at the sine of these three different triangles? And what I wanted you to capture was the following. Hopefully you noticed that the triangles were all the same angle measures. Okay, if this is 36.87 and this is 90, this would be whatever this adds up to be 90 degrees. But what I'm trying to do is make you notice that despite the angle measures remaining consistent, the side lengths were changing. Whether if we consider this being our original one, it went smaller, or if this was our original one, it went bigger. So what we call is that these triangles are called similar triangles. They're not congruent because in order to be congruent, you would want all lengths to be the same. We'd want all angle measures to be the same. But notice that the ratio of the lengths always remain the same despite the size, the overall size of the triangle. Okay? So here is just a calculator portion, this part right here. And here's what you want to make sure. Whenever you are using these three buttons here, the sine, cosine, or tangent, I need you to always make sure that you go to mode, okay, and make sure that you select the degree, okay? It's not until like pre-calculus that you would use the radian mode. So grab a calculator in the classroom. Please make sure that you are in degree mode while we are in this trig unit, okay? And I'm going to second quit, and I'm going to find and evaluate the sine of 36.87 using the calculator. Okay, so you would type the sine button, type the value 36.87, which is the angle. We're taking the sine of angle 36.87 degrees, and I'm going to hit enter. Okay, and that is 0.60. So over here I'm going to say it's approximately 0.60. But what I want you to notice is that this is the same value as these three, even though we use the same calculator. Even though we use the calculator, because 3 divided by 5 is 0.6. And that's what we got when we used the calculator. Okay? So what I want you to do is I want you to do the cosine values and the tan values of these same triangles and notice what occurs. Okay, so pause the video now and do that, and then check your answers. Okay, I'll give you about 2 minutes. Take about 2 minutes. Okay, so here's the table, and you can pause it here to check your answers, but these are the values that you should have got. And again, you could have checked, if you put 4/5 in the calculator, you would get close to 0.8, 3/4, gets close to 0.75. So the basic gist of this table is just showing you how similar triangles will still maintain the ratio values. And it kind of supports what we learned in the last unit with similar triangles. So let's look at our examples here and practice a bit. So example number 1. So example number 1, it says for triangle RST, they want us to write each trig ratio as a fraction and as a decimal rounded to the nearest hundredth. So the nearest hundredth, 100 has 2 zeros, so we want 2 decimal places, right? So 2 decimal places in addition to the fraction, okay? Because they wanted us to do it as a fraction and as a decimal. Okay, so 2 different ways to represent. So let's look at the sine of r. So notice in part A, B, and C, they will tell us where the angle we are supposed to stand on. Okay, the angle r is what we are needing to focus on. So when you decide where you are standing, okay, as soon as you label where you're standing, whether you highlight it, circle it, I need you to label the lengths of the sides as O, A, or H. So if I'm standing right here, the first thing I always want to label is my H. So here's my 90-degree angle, so I know these are my legs, and those are only for opposite and adjacent. So that means my slanted side across from 90, that's my H. So I'm going to put an H there. So O and H, O and A, which one? So I have to, eeny, meeny, miny, moe, no, not exactly. You're standing here, let me start with opposite. What is across from me? Opposite means across. Well, the side across from me is my opposite side, so this is O for opposite. So this one has to be my adjacent side, okay? So hypotenuse, adjacent, and opposite. So all I need to know is my formulas, or my, terminology for sine, where sine is opposite over hypotenuse. The opposite length was 12 over the hypotenuse length was 13. So there's my fraction answer, and I will go into the calculator. 12 over 13, it is 0.9230769, etc., but I'm only interested in 2 decimal places. So I'm either going to do 0.92 or 0.93. Now, depending on the number next to that, I'll round up or keep it the same. Since it's a number less than 5, I will keep it at 0.92. So 0.92 is what I'm going to put here. And for those of you asking, do I have to put 0.92? No, you don't. I just like the placeholder. Okay? Cosine R. Well, again, we're standing at the same angle, so I don't have to go label anything. Since we're standing at the same angle, the labels stay the same. So A is the length of, what's that number? That looks like a 5. The H was 13. Again, do the calculator portion, and you get that. So pause the video on this one and do tangent for me, okay? All right, so hopefully you are back now. Tangent was opposite over adjacent. You should have put 12 over 5. And the decimal value you would have got was 2.4. Okay? All right, so example 2 is just merely you practicing using the buttons on your calculator. So go ahead and pause here as well and get these values. Like this says right here, make sure you are in degree mode. That's very, very important. So go ahead and do that, pause, and then come back to me. Okay, so at this point, go ahead and check your calculator work for example number 2. And then what I'm going to want you to do is pause the video again and go ahead and copy down the following steps that I have written out for example 3. Okay, so I'm going to read them out before I have you pause. We are going to find the length of certain missing sides in a given triangle. And so there are certain steps that I'm going to want you to follow, and the steps are the following: 1, 2, 3, 4. So the first thing you will always want to do is find the acute angle that you are going to stand at, okay? Where is it? Where's your point of reference, okay? And your point of reference must always be an acute angle. We will never stand at the 90-degree angle, okay? So you have a 50-50 chance, and usually it's pretty obvious what you're going to stand on, because they'll either tell you specifically or they'll give you a number within the angle degree in degrees so that you know where you're supposed to stand. So that's first step. Second step, label the hypotenuse, the opposite, and the adjacent side, and you just need to use the letters H, O, and A. No need to write them out. And then we will discuss about 3 and 4. Okay, so go ahead and write those steps out, and then we will talk. Okay, so here's what we're going to do on setting up the equation. So the first thing you need to do is find the acute angle. So here's our acute angle. So we know it's labeled with a degree. So we are going to look for everything by standing in this acute angle. From this perspective, I have to label my hypotenuse, opposite, and adjacent. Always label your hypotenuse first. So here is going to be my hypotenuse. Again, I'm just writing out the letters, but HOA is sufficient. Standing from here, looking across will always give me my opposite. So this is my opposite side, and my adjacent side is always the leftover side, the leftover leg. Okay? So that's the second step. The third step, I need to highlight two things, okay? I need you to highlight the unknown length, the length that you're looking for, and the given length that has been provided to you in this picture, okay? Since I'm looking, this is my unknown, okay? Find the length of AB, that's my unknown, that's what I'm looking for. Length of AB is this length right here. And in math, usually we use variables, not usually, we do, and we usually use the letter X, so I'm going to let AB be the letter X, because that's my unknown, okay? So highlight the unknown length, so I'm going to highlight by just kind of scratching through here, the X, and I need to, and I'm going to actually highlight the word adjacent first. And then I need to highlight the given length, and my given length was the 6.1. Nothing was given here for hypotenuse. So I'm going to highlight all this side, okay? So that's step number 3, super easy, okay? So now set up the equation and solve. The way you set up the equation is looking at what was highlighted. O for opposite and A for adjacent was what was highlighted. So if I focus on my mnemonic, okay, which is this one right here, O and A was what was highlighted, so that means this here is the setup of my trig function that I'm going to use. So I'm going to set it up by writing T for tangent, so I'm going to write the tangent. I write down the angle where I'm standing at, 41 degrees, equals, it has to be a ratio, opposite over adjacent. This one always goes in the numerator, so this one, and this one always goes in the numerator. This one, and this one always goes in the denominator. So O for opposite, O was 6.1, and A for adjacent was my X. See, there was my O, there was my A. Okay? So, now I'm going to solve for X. What I tell students is it's always easier if you have a fraction equals another fraction for you to visualize. So I'm going to put a very light 1 here. And notice I'm doing it really lightly just to make a point, just so you can see that that's a fraction equals another fraction. And what did we do last unit? We would always cross multiply when we were solving, okay? We always cross multiply to solve our equations. So I always say, when you cross multiply first with the one that has the X. So this and this one has the X value. So X tan 41, so I'm going to write X tangent of 41 degrees equals 1 times 6.1 is just 6.1. And since I want to solve for X, the X is right here, and it's being multiplied by tangent 41, so I need to get rid of that. And I can only do that by dividing both sides by tangent of 41 degrees. So I'm going to divide this side by tangent of 41, and this one by tangent of 41 degrees. So now my X has been isolated, and I'm just left with calculator work. Okay, so I'm going to come over here. 6.1 is my numerator, 6.1, and I need to divide it by tangent of 41 degrees. When I hit enter, I have 7.01724, blah, blah, blah. I'm going to round it to, let's make it 2 decimal places. So 7.02. So since I'm rounding, I'm going to put some approximate signs. 7.02 is the length of AB, which is what we were looking for. Okay, so let's practice again with the other triangle. Okay, example number 4. So I'm going to do this right here just to have a difference. So let's go ahead and have you set up the equation over here. And so pause at this moment and then unpause when you're ready to see the answer. Okay, so let's see if you were right. So first step, find the acute angle. The acute angle for us is going to be the 20 degrees. So I know I'm standing right here at angle N. Okay? Step number 2, label the hypotenuse, opposite, and adjacent. So if I'm standing right here, hypotenuse is my slanted side across from the 90 degrees. If I'm standing over here, my reference point is angle N. Opposite is going to be this side over here. And adjacent is the other side that's left over. Okay? So they want us to find the length of MP. MP is this one. MP, so here is my X. I'm going to put X right here. This question mark. Okay? So I need to highlight the unknown length. Well, the unknown length is length of MP, which I'm looking for. So I'm highlighting very lightly here. Then I'm highlighting the given length. The only thing that was given to me was here, the hypotenuse. So I'm highlighting. And then I'm going to set up my equation. Again, based on what was given to me, the O for opposite and hypotenuse. So notice that the one we're going to use is going to be the SOH. Okay? So I'm going to write down the mnemonic over here again. And you don't have to do it every single time, but for notes, I like to be very detailed. So here's O and H. O and H was the winner. So that's my trig function that we need to set up. Sine is equal to opposite over hypotenuse. Don't say sin, by the way. A lot of students like to say sin. It's not sin, it's sine. The actual word is S-I-N-E, okay? But we drop the E for your shorthand purposes, but we still pronounce it, okay? Sine. The sine of what angle? Tell me where you're standing. What acute angle? Notice that's less than 90 degrees. Less than 90 degrees, okay? So you're always standing at an acute angle when it comes to right triangle trigonometry. You'll notice afterwards that that's going to change in the future, but for now, they're acute. So sine of 20 degrees is equal to O over H. So O was my X, so that goes in the numerator, and my H was 8.7, and there's my equation that is ready to solve. I need a cross multiply. So cross multiply needs a fraction. So again, I'm going to put a very light line here to give me a visual. And I need a cross multiply. So make that X. And look for the one that has an X. So start with that one. So this little circled portion has the X. Remember this one over here had the X? Now this one here has the X. So 1 times X is just X. So I'm going to write X equals. And then this right here is going to be 8.7 sine of 20 degrees. And notice how cool this is, because here my X has already been isolated. I don't have to do anything else but just plug it into the calculator. Over here, the X was not isolated. It actually looked like this before we isolated it. You see, the X had some company, X tangent of 41, so I had to divide both sides to get my X to be by itself. That's not the case over here on this side. Do you see? So notice that that is the difference between these two. And these are the only two differences. These are the only two scenarios that you will see always, okay? So let's type it in as we see it. 8.7 sine of 20 degrees. Hit enter. And so my X is going to be approximately 2.98 units in length, which is, what's the length of MP, which we were looking for? That was the length of MP. So, boxing in the answer, and there we go. Okay, so this is what I'm expecting you guys to do for your homework that I want you guys to have completed for the next time that I see you. Some of you tomorrow, some of you on Wednesday. So I want us to do at least the first one or the second one, but here's an example, and I suggest that you at least do the following. Go ahead and write down the mnemonic at the top, and then the first thing I want you to do is that, how as I did here, is I want you to label the sides of the triangle opposite, adjacent, and hypotenuse. And I know it doesn't say here, but I do need you to solve for x, okay? When you're done, go ahead and solve for x. So for instance, on this one right here, my acute angle was 28, so I labeled my H, and I labeled my O and my A. And let me erase this. I don't know why I have it worked out for you already, because I need to kind of talk you through it. Let's do this. Hold on. It's kind of rushing it here. So if I'm standing right here, the first thing I need to do is label my H, my opposite, because it's a cross, and my adjacent, okay? Then the second step is highlight your unknown length. Well, my unknown length is my x, so that's why I'm highlighting this side, okay? And then the side that I do know, so I'm highlighting this side. All right, so based on AH is this one right here. So I'm going to start off with cosine, tell the teacher the angle you're standing at, and then adjacent is the 13 over H was the x. So there's your equation set up, ready to go. And there I'm going to put my little light line to show it's over 1. So I'm going to cross multiply. So I'm cross multiplying here and cross multiplying here. So these two together become x cosine of 28 degrees equals 1 times 13 is 13. My x here is not alone. So that means I need to divide by what I need to get rid of so that I can cancel it out. So, bam. So x is approximately equal. Make sure the calculator is in degree mode. So I'm going to put 13 divided by cosine 28. And the answer is 14.7. Looking around to the nearest tenth. I think that's what the answer key had. I can't remember. So 14.7 is our answer, and we're done. And so I want you guys to box in. Okay. Let's do one more. Again, find your acute angle. I'm standing here. Use that to label. Well, my H, standing here. Across is opposite, and A is the leftover one. Then you will highlight the unknown length. My unknown length is the length I'm looking for. They want us to solve for x, so this is my unknown. So here's me highlighting. Highlight the side length that was given. The length of the hypotenuse was given to be 19 units, so I'm highlighting this. And using what I highlight, OH, backtrack, OH is right here, SOH. So S for sine, not sin, sine of the angle equals opposite. Opposite, I didn't know what it was. H, I did know what it was. And now cross multiply. Always cross multiply. So here's my little faint line, and I'm going to kind of visually, that was ugly, visually give myself the cross multiplication sign. Start with the x side, the x cross, which is this one. 1 times x, x equals, multiply the other side, 19 sine of 15. And this is the scenario I like because x is already solved for. There is nothing for me to do. So I'm done. I just type 19 sine of 15, and I get x to be the approximation of length 4.9. Box in my answer, and I'm done. So super easy, super easy. So if you all would please do the remaining 10 problems, check it against the answer key that I have sent to you. You should not have any issues with this, and if you do, just text me, okay? Have a good evening, and thank you so much for listening.